Hello everyone, and thanks for watching Edupedia World videos. My name is Manish Agrawal and I'll be teaching you physical chemistry, and in this course we'll cover physical chemistry part of class 11th. Please note that in this section, in fact in this complete course, we'll take NCERT book of class 11, that is the textbook for CBSE board, as a reference for syllabus, but the topics which we'll cover are going to be standalone in their nature. That is, you won't need to refer any other textbook or any other material to understand what we are teaching over here. Obviously, it is always better to have a textbook or some material for practice and to further your understanding, but you can understand and learn everything from what we'll teach you in these slides. Alright, so let's start with our syllabus. And before we do, first you need to know what exactly is physical chemistry, because until now you only studied subjects as chemistry, physics and biology, but for the first time we have subdivided chemistry into three different sections: physical chemistry, organic chemistry and inorganic chemistry. So what do we understand by chemistry itself? Well, chemistry is nothing but study of properties, composition and structure of matter. Alright, so when we say physical chemistry, we basically mean it from 2 points of view. First is that when we study properties of matter, we study physical properties of matter. Alright, so in physical chemistry we focus upon physical properties, whereas in organic and inorganic chemistry we focus upon chemical properties of matter. Alright, and second and more important point in physical chemistry is it uses physical analysis and physical tools to study matter. Right, so we would take a lot of laws and a lot of theorems from maths and physics and use them here in chemistry. For example, differential and integral calculus, right? For example, energy calculations, force calculation, all that will be used here in physical chemistry. Yes, so now you have a basic understanding of what physical chemistry is. What are its applications? Well, obviously there are numerous applications. Like with every subject, physical chemistry is used in manufacturing of pretty much everything that you see around yourself, especially based on chemicals. For example, your beauty products, your toothpaste, alright, all the FMCG products, even your mosquito coil, oil, diesel, fertilizer, they are all done by chemical engineering. Okay, so the manufacturing is done by chemical engineering, which uses the concepts of physical chemistry. So now, since we have a basic idea of this, let's see what we'll cover in this session and in the coming up course. So first we'll obviously start with mole concept and then atomic structure. These are the basic topics of your physical chemistry, as they give you a deeper understanding of what atoms and molecules are. Alright, and how do we quantify them, and how do we calculate those quantities. Apart from that, we'll study redox reactions followed by states of matter, then chemical and ionic equilibrium, and lastly, but a very important topic, thermodynamics. Alright, so we'll also study them in this particular order itself, and this will pretty much cover everything of your physical chemistry of class 11. Alright, so for today's session we'll start with some basic principles which you have pretty much studied in your earlier classes, even in your class 6th, 8th and 9th and 10th. Alright, and apart from that, you will also study these basic principles in physics and maths. So here we'll just give you an overview so that you know what we are referring to in future classes when we study them. Alright, so basic principles would include units and measurement, then significant figures and rounding of numbers, unitary method, again this you have studied in maths, atoms and molecules, followed by a little overview of states of matter, and then we'll start with our core topics like mole concept, atomic structure and so on. Alright, so let's begin with our basic principles. Okay, remember that these principles which we are going to study, you have already studied them, and some of them you'll study in much deeper level in physics and maths. So here we are just giving you a review of those topics. Okay, so if you are completely unaware of them, refer a textbook or refer your physics lecture. I'm sure they will contain units and measurement and significant figures in detail. Okay, so let's move on. Units and measurements. So first you need to know are some important base quantities. See, when we say measurement and when we say unit, what do we mean? When we say measurement, we mean that how do you quantify something? For example, your height is 3 meters. So how do I quantify your height? I quantify it by measuring your height. I take a scale, put it adjacent to you and see the reading. So measurement is a physical activity, whereas units is what makes sense of our measurement. I said your height is 3 meter. I didn't say it is 3 centimeter or 3 kilometer. So that meter, centimeter, kilometer, this gives us sense of our measurement. That is what we understand by unit. So these units and these measurements, okay, these are used pretty much in every subject. Okay, and here we'll look at some of the base quantities. Base quantities as in base units, which can be used to derive every other unit present in the world. Okay, so there are 7 base quantities which you must have already studied in physics, out of which some will use in chemistry. First is temperature. Okay, temperature, it is often represented by capital T and its unit is Kelvin. Okay, so this capital T for temperature is just an alphabet to represent the term temperature. Alright, there is no hard and fast rule to use capital T. You can use A, E, O, whatever letter you like. But this capital K for Kelvin, it is a standard unit. Alright, it is accepted by International Federation for Units and Measurements. So you cannot change that. Apart from that, you also know that units are studied in different systems. For example, SI system, CGS system, metric system. Okay, so here we'll take only SI system because it is the most accepted one and it gives a clear common ground to refer to our measurements. Okay, apart from that, we'll also study CGS system because still in a lot of books you will, and even in your questions in exams, you will find reference to CGS system. So you need to know both and you need to know the conversions between them. So for temperature it is easy because both in SI as well as in CGS system, its unit is always Kelvin. Okay, then mass, it is often represented by small m. Its unit is kilogram, which is represented by kg in SI system, and it is gram in CGS system, which can be represented either by gm or just g. Alright, so next base quantity is length. It is often represented by letter L and its unit in SI is meter and in CGS it is centimeter. Then we have amount of a substance. Now this is a very important quantity and this is what we are going to majorly use in all of our chemistry studies. It is represented by mole. Alright, so the unit of amount of a substance in chemistry which we'll use is mole, and it can be written as MOL as well. Okay, and we'll study this in a lot of detail in our topic of mole concept. Don't worry about that. Apart from these 4, there are 3 other base quantities, which is time, measured in units of seconds, and then there is luminosity and current. Okay, we'll not go into them right now, and if we need to use them somewhere, we'll see what they are. Okay, so why we call them base quantities? Like I said before, because we can derive every other quantity using these 7 base quantities. For example, let's say you have volume of a substance. Now the quantity volume is what? It is nothing but multiplication of length, breadth and height. Okay, so it is simply cube of length. Okay, so volume can be measured as cube of length and its unit will be cubic meter, that is meter into meter into meter, or in CGS system it will be centimeter multiplied by centimeter multiplied by centimeter. Similarly, let's say we have pressure, often represented by capital P. Its unit is Pascal, that is PA in SI system, or we can also use kilogram per meter square. So what I have done is I have derived the unit of pressure using unit of mass and length, kilogram per meter square. Okay, and in CGS system its unit will be gram per centimeter square. Alright, so this is all for units and dimensions, and again this topic will be covered in your physics lectures in great detail, and you need to know this topic. It's very important for your further studies. Let's move on to the next basic principle, which is of scientific notation. Again, we'll only review the topic and just focus upon what we need in chemistry. So in chemistry you need to know how to represent any number in terms of scientific notation. Let's say you have 16,000, 16000. How do I write it in scientific terms? I write it as 1.6 into 10 to the power 4. Okay, so this is what we mean by scientific notation. The term on the right hand side of equality is scientific notation of 16,000. Similarly, if you have 1406, 1406, in scientific notation you write it as 1.406 into 10 to the power 3. And again, if you have 420, you write it as 4.2 into 10 to the power 2. Now please note here that this number of significant figures cannot be changed while writing a number in scientific notation. So here in 16,000, if we look at it again, in 16,000 we have only two significant figures, 1 and 6. So while writing in scientific notation we have written it as 1.6, not 1.60 or 1.600. Okay, so the number of significant figures must be maintained. Again, 1406 has 4 significant figures. So on right hand side again we have 4 significant figures, 1.406. 420 has only 2 significant figures, 4 and 2. The 0 here is not a significant figure, so we have written it as 4.2. Alright, if the number was 420.0, then there would have been 3 significant figures, 4, 2 as well as 0. And on right hand side, in that case we will write 4.20 multiplied by 10 to the power 2. Okay, so the number of significant figures on both sides must be maintained. Similarly, if the number is 0.00016, that is 0.3016, in scientific terms it is written as 1.6 multiplied by 10 to the power minus 4. This time the power of 4 will be negative. Why? Because effectively what we have done is we have shifted the decimal point 4 digits to the right, or in other words we have basically divided the number by 10000. Okay, so we have divided the number by 10,000, which means we have multiplied it by 10 to the power minus 4. Similarly, 0.9211 can be written as 9.211 multiplied by 10 to the power minus 1, and 0.001 is written as 1 into 10 to the power minus 3. Again, the number of significant figures on both sides must be same. We cannot change the number of significant figures. So 0.001 has only one significant figure, which is 1. So even on right hand side we have maintained the same number of significant figures. So you need to know about significant figures. More importantly, you need to know how to write scientific notation, because your questions a lot of time they will be represented in scientific notation and you will have to answer correspondingly in scientific notation. Apart from that, you must also have basic knowledge of rounding off of digits. Alright, for example, if you have 4.667, so I can round off it as 4.67. Okay, you know all that. So you just need to have a basic understanding of that, so that your calculations can be made easier. In exams you won't be allowed to use calculator, not until you get into college. Okay, so let's move on to the next basic principle, which is the unitary method. Now this is a very basic topic and you must have studied it in class 6th or class 8th in your mathematics subject, but we'll just give it a quick review over here. Okay, so when I say unitary method, what do we mean by unitary method? Well, it is a method for counting. It is a method for counting and determining the unknown quantity using cross multiplication. Alright, so unitary method is nothing but a method for counting and determining the unknown quantity using cross multiplication. So once you have a knowledge of unitary method, you can solve complex questions relatively easier. Let's say I have a question which says that 3 oranges can give me 2 glasses of juice. Alright, 3 oranges can give me 2 glasses of juice. So how many glasses can I obtain from 5 oranges? So what did I tell you right now? That unitary method is nothing but cross multiplication. Okay, so unitary method is nothing but cross multiplication. So what we do, we write the question in this format: 3 oranges gives me 2 glasses of juice. So 5 oranges, let's say, will give me x glasses of juice. So we have to calculate x. So to calculate x, what you need to do is nothing but cross multiply. That is, multiply x with 3 and multiply 5 with 2. So what do I get? 3 oranges multiplied with x is equal to 5 oranges multiplied with 2 glass. So x is equal to 5 orange divided by 3 orange multiplied by 2 glass. So x is equal to nothing but 10 by 3 glass. So 5 oranges can give me 10 by 3 glasses of juice, that is 3.333 glasses. Okay, so you get the idea of unitary method. Just write everything in this format. Okay, write everything in this format and then cross multiply. Okay, and you can calculate the unknown quantity. Let's take another simple example. Say I have 7 pens and I sold 7 pens for 14 rupees. I sold 7 pens for 14 rupees. So how much money can I obtain by selling 21 pens? This is your question. So what you do, you write it in that format. 7 pens gives me 14 rupees. Okay, so 21 pens, let's say, will give me x rupees. Now cross multiply. Okay, so cross multiplication gives me 7 pen multiplied by x is equal to 14 into 21 pens. So x is nothing but 14 rupees multiplied by 21 pens divided by 7 pens. So x is equal to 3 into 14. Okay, which is 42 rupees. So upon selling 21 pens, I can obtain 42 rupees. Alright, so it is very easy. You can solve them orally. You have already studied this in your lower classes of mathematics. But when it comes to atoms and molecules and calculating their quantity, okay, so you cannot do it on your fingers. The number of atoms and molecules are, say, 10 to the power 23, 10 to the power 100 and so on. So to calculate them, it is easier to do it using unitary method, so you don't mess up your calculations and commit silly mistakes. Alright, so this is it for the basic principles for today. Okay, apart from this, we obviously have a lot of ground to cover in our topics of mole concept and atomic structure, but these are the principles which will take as prerequisite before we move on to them. Okay, in the next session we will cover atoms and molecules, what exactly is the difference between them. Again, you have studied this, but we'll just give it a quick review, but in a little more detail, because I have found that a lot of students even in their class 11 are confused by the concept of atom and molecules, and what exactly is the difference and how do we note them while writing atom and molecules, for example H2 or just H. Similarly, we'll see what states of matter mean. Okay, so until next time, and once again thanks for watching Edupedia World videos.